Hey guys! Today we're going to be talking about the nature of science. But what is science really? Let's look at a few definitions of science. Science is a systematic enterprise that builds and organizes knowledge in the form of testable explanations and predictions about the universe. Or science is the intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experiment. Well, those definitions seem a little confusing. It can be hard to try and explain to someone what science is. To get a better idea of what science is, let's take a look at what science is not. We're going to look at some of the top myths there are about science. Myth number one is that a hypothesis can become a theory, which can become a law. This myth stems from the idea that there is a hierarchy of steps that scientific ideas go through, as the image shows. This is not truly the case. In reality, this is a better representation of scientific hypotheses, theories, and laws. While it may be true that many hypotheses can become part of a theory with enough evidence, theories and laws are two completely different types of scientific knowledge. Let's take a closer look at theories and laws. The word theory has taken on a different meaning when it is used in everyday conversation. It is used when people really mean, I have an idea, or thought. A scientific theory has more to it than a regular thought. This everyday use of the word theory has led to some confusion about scientific evidence, especially when it comes to the debate surrounding evolution. In a 1980 speech, Ronald Reagan famously dismissed evolution by saying, "Well, it's a theory. It is a scientific theory only," when suggesting that evolution and creationism should both be taught in the science classroom. If Ronald Reagan knew more about the nature of science, he may not have dismissed this theory so easily. Scientific theories are well-supported explanations of occurrences in the natural world. Reagan would probably not brush off Einstein's theory of relativity or atomic theory as only a theory. A generally accepted scientific theory has not been disproven despite rigorous scientific testing and is considered to be the best idea about why a phenomenon occurs. Unlike theories, laws are descriptions of the natural world, not explanations. They are observations that occur over and over again. The law of gravity describes how objects are pulled toward each other, like how we are pulled toward the Earth, and the ideal gas laws describe how ideal gases behave. Because laws are descriptions and theories are explanations, a theory will never become a law. One especially pervasive myth about science is the myth regarding the scientific method. Many science students learn that there are 6 or 7 steps in the scientific process: problem, hypothesis, experiment, observation, analysis, and conclusion. A research step may also be added into the process. While this step-by-step process is fairly easy to follow, the real story of scientific processes is something much different. This graphic gives a better picture about the process of science. Instead of a linear path, real science is a cycle with no real beginning or ending. As you can see, the process includes making observations and doing research to develop a question, and gathering and interpreting data to form hypotheses. Some additions to this version of the scientific process are community analysis and feedback, which includes peer review and experimental replication, and benefits and outcomes of scientific studies, like the development of technology and ability to solve problems. As this graphic shows, science is not a linear process with exact steps. Another major myth about science is about how scientific knowledge is collected. Many people think that this is the only way to collect scientific data, while wearing a white coat and goggles and using tons of equipment in a laboratory. In reality, science can be done nearly anywhere with little equipment. The idea behind science is the ability to describe the natural world. Science fields like ecology and geology are done mostly in our natural environment, making observations. The white coat is not even required. Myth number 4 about science is the idea that science always gives clear and definitive answers to questions. First of all, though labs done in science class may lead you to a specific answer, this is not usually the case in scientific investigations. Experiments can lead to failed or unexpected outcomes, and often hundreds of trials need to be run before enough data has been collected to propose a hypothesis. Additionally, successful experimentation cannot necessarily definitively answer a question. Because science knowledge is based on continued observation of the natural world, science cannot prove a hypothesis to be true. This is because there is no possible way to make all possible observations. Instead, science provides the best explanation based on available evidence. New discoveries can change what people know about science. These are just a few things that have changed due to new scientific evidence. We no longer accept spontaneous generation as the main theory of how life happens because of the acceptance of cell theory. We no longer believe that the Earth is the center of the universe. And modern genetics tells us that pre-formation is not the way that traits are passed through generations. While theories can change based on new evidence, this is not to say that scientific knowledge cannot be trusted. Science knowledge is rigorously tested through repeated experimentation and peer review before acceptance by the scientific community. When theories change, it is often because of the invention of some technology that allows scientists to observe in a way that they hadn't been able to before. Science is still the best way we have to make inferences about the natural world. Another common myth about science is that it is unbiased. Though it's true that science knowledge is based on empirical evidence, the analysis and process of science is vulnerable to the biases of scientists. Like every other human, scientists also have biases that influence their work. There have been many historical examples of biases in the scientific community, making it difficult for new evidence to change what is commonly accepted as correct. It took a very long time for society to accept that the sun is at the center of our solar system, because they were used to the idea that the Earth was at the center of the universe. Human and societal bias in science was a problem for Gregor Mendel, the father of genetics, and his pivotal work with pea plants. Because Mendel was not part of the scientific elite of his time, and because his work was so revolutionary, the scientific community did not take his findings about heredity seriously. It wasn't until after Mendel's death that his work was rediscovered and recognized as some of the most important findings in the history of genetics. The next myth about science is that science is not a creative process. This could not be farther from the truth. Science knowledge is gained through the creativity of individual scientists. To start with, scientists come up with questions about the world because they are curious about something and want to find out more about it. Once a scientist has a question in mind, they come up with an experiment to answer a specific question. Though they may borrow similar techniques from previous experiments, the experiment is tailored to each individual question. Once data is collected, scientists must analyze the data for patterns or trends. Every aspect of the process of collecting and analyzing scientific data involves creativity by scientists. The field of science is truly fueled by creative individuals. Knowing about what science is and what it isn't can help in having a deeper understanding of science knowledge and the processes of science. By addressing science myths, we now have a little better idea of what science is all about.